Before I go over question number 33 from practice test AB-2, I have to make sure I go over this. I have two functions here, f and g, and I'm told that f is an even function and g is an odd function. An even function means if you put in a negative number, you get the same thing as if you had put it in without the negative. So an example of an even function is absolute value of x. Because I can put in a negative number here like negative 5, and that would be the same as if I just put in positive 5. These two are the same thing. And then for an odd function, if I put in a negative value, I can bring the negative on the outside of the function. So an example of that is sine of x is an odd function. So if I put in negative pi over 2, well, sine of negative pi over 2 is negative 1, but I can bring the negative to the outside and rewrite this as negative sine of positive pi over 2. And sine of pi over 2 is 1, and then you have the negative right here. And our goal is to find out whether their derivatives, the derivative of any even function, is odd or even, and the same is the derivative of any odd function, odd or even. So I'm going to erase this. And let's get to work. So I'm going to copy this. We'll do the even function first. So I'm going to copy this down. F of a negative x equals positive f of x. This is our definition of the even function. And I'm going to take the derivative on both sides. So I'll do d dx and do d dx. On the left side, derivative of f of a negative x. Well, first we're going to have f prime, and then the inside stays the same. But then we can't forget the chain rule, multiplied by the derivative on the inside, which is a negative 1. Just to make it clear, this is the negative 1 is not inside the f prime. And then on the right-hand side, derivative of f of x is just f prime of x. And I'm going to divide both sides by negative 1 to bring it over to the other side. Divide by negative 1, divide by negative 1, and then these are going to cancel out. And on the left side, I'll be left with f prime of negative x. And on the right side, I will have this negative 1 right here. I'm just going to write it as a negative sign in the front. And I'll have the f prime of x right here. This is precisely the definition of an odd function. If you have it put in a negative, you can take the negative on the outside. So we found that the derivative of an even function is odd. Now I'll erase all this so we can do the same thing for our odd function, g of x. So I'll copy this down again. G of negative x equals negative g of x. And once again, I will take the derivative on both sides, so we'll do a d dx and a d dx. And again, on the left-hand side, derivative of g is g prime. The inside stays the same, but then by the chain rule, I have to multiply by the derivative in here, which is a negative 1. I'll just put it down in the front, and you don't really need to write the 1. You can just leave it as a negative sign in the front. This will be equal to, don't forget about this constant multiple right here of a negative 1. I can take that on the outside, and then the derivative of g of x is g prime of x. Now the negatives cancel because we've got one on each side of the equation. That's supposed to be in blue. Cancel, cancel. You can do that however you want. You can, multiply both sides by negative 1, and both sides by negative 1. I'll just erase them. And this is precisely the definition of an even function. It's the same whether you put in the negative or the positive input. So our conclusion is that the derivative of an odd function is even. Now before I move on to the problem, think about this for anti-differentiation. Yes, it works the same way. If you start with an even function and take the antiderivative, you're going to get an odd function. And if you start with an odd function and take the antiderivative, you'll get an even function. That being said, let's take a look at problem number 33. So we've been given a function, and we're told that it is even. You might want to underline that on your paper so you don't forget it. And we have to figure out which of these are the same as this expression right here. Now, I'm just going to make a note here that the fundamental theorem of calculus part 2, that's literally this right here, tells us what it equals. Equals capital F of B minus capital F of A, where capital F is an antiderivative of little f. And now let's take a look at our choices. So the first one, we're looking at the integral from a to b of f of a negative x dx. Well, we're told that f of x is even. So as we just saw, I can cross out the negative. I can get rid of it. It's like it's not even there. I'll just put an x through it. So these two are precisely the same thing. These are just two different ways of writing the same thing. So we know that this is good. This is, number 1 is equal. So I can cross off my answer choices that don't involve number 1. So I can cross this off, and I can cross this off, because I know that those are not correct. All right, number 2, the absolute value of f of x. Now, don't get confused. Just because f of x is even doesn't mean that everything it puts out is also even. It can put out negative numbers. So if you take the absolute value of an even function, that could change it. So we don't know that this is true. It can be true, but it doesn't have to be, because it says here must be equal to. So we can now cross off any choice that involves number 2, because we know that that's not it. All right, now for number 3, we have to actually work this out. We can use a property of integration that says I can switch the order of these limits if I put a negative sign in the front. Negative sign. So I'll put down negative. This equals the negative integral from negative a to negative b of f of x dx. And I can work this out using the fundamental theorem of calculus. So firstly, I have the negative still in the front. So the fundamental theorem of calculus states that I can evaluate this by finding an antiderivative, evaluating it at the upper limit, which is negative b now, and then minus the same antiderivative, evaluated at the lower limit. And don't forget the close parentheses, because this is all within the negative, this negative in the front. And let's go ahead and distribute that negative. So I'll get negative capital F of negative b minus becomes plus capital F of a negative a. Well, if little f is even, if you take the antiderivative of an even function, you're going to get an odd function. So our conclusion is that capital F is an odd function. So I can take these negatives and bring them on the outside. So when I have negative, it's going to become a positive capital F of positive b. And then I brought the negative here on the outside, so it's now going to be minus capital F of a negative a. And now take a look at these two. These are the same. So our conclusion is that statement 3 is correct because it's equal to this. So we know that the answer is choice E, statements 1 and 3.